Hello everyone. This is a project that I have been working on for a while now, as far as getting it set up, getting all the stuff that I need, and just getting everything together. It's been a while in the making, but I finally have all the parts now to get this done. And essentially what I've wanted to do is I have one of these Flash Forge Creator Pros. Flash Forge printer here, and anyway, I have several of these things, and one of the things that I've been wanting to do is I want to turn this into a CNC machine, CNC router machine. And as you guys know, additive technology is different than subtractive technology. In other words, see, if you take something that's made to print something by adding material to and building up, then it's one thing, but if you want to subtract, it's another. Now, doing research for doing this project, one of the things, stuff falling around here. All right. One of the things about these 3D printers, and this is modeled on the MakerBot. One of the things about this is it has the Mighty board right here. And this Mighty board is great, but it's really a pain in the butt to try to set up to do a CNC milling. Now, some of the parts that are in here is the power supply. We can use that. We can use the motors. We can use any of the limits and stuff that are in here. But this board's got to go. And what I'm going to be replacing it with is something completely different. So let me get that set up, and I'll show you what we're going to do. Okay, so here's what I have. Another one of these Flash Forge MakerBot copies here, and everything's been basically everything that's not going to be used is stripped out of here. The hot plate, all of that stuff. The Z-axis is still here, and the holder's still here. I'll show you what I did about the holder here in just a second. Underneath, the Mighty board has been stripped out. All the things that I'm keeping are here. I am going to attempt, now I don't know if I'm going to be able to do it or not, but since this is based upon, the Mighty board is based on the same chipsets and stuff as an Arduino, I'm going to try to reuse the buttons on the front, which are right here, these, and I don't know, but I want to see if I can't possibly try something with the LCD, and all that comes through this cable right here. So this is the communication. I'm not sure yet. I haven't really got into that part of it yet, but no big deal. Power supply. I'm using the exact same stepper motors, so I'm going to use the exact same power supply to power them. And so that's the stuff with the case. Let's go over here with the new stuff, the goodies. All right. First thing, the build plate for the 3D printer. This is one of them. It's some nice hard anodized aluminum, which is great, but it's no good for doing any CNC work. So what I did was I built myself a build plate. I came in here and basically just routed out so this just fits in there nice and snug. Virtually no movement, and so that way you can basically put this in to the CNC machine. When you're done, lift it out, do whatever you want to do with your part, put a new piece back on, slip it in, lock it down, and then let it go. I'm hoping that that'll make things a little bit easier, because this is inside of a small frame, and there's not a lot of tolerance there to mess around with stuff. So I figure it'd be easier just to be able to take the build plate out, and if this gets damaged, just make another one, no real big deal. So it should make it a little bit simpler. So that is that for the build plate. Then this. Okay, what I'm going to do is reuse the motor drivers that came off of the Mighty board, and I got this, which is the CNC shield for an Arduino. And this, essentially, you just put these motor drivers in here, and for each axis, which I'm only going to be running 3 axes on this one, because the 4th axis, it's not going to be used in this. It would be if I was doing a 3D printer or something, but for the extruder, but not going to be using that. So essentially what I'm going to do is I'm going to hook up all of my axis, and I'm going to set up all my limits, and there are some stuff in here for controls and everything, and that's something that I'm going to be setting up in a future video here. This is more of an introduction as to what we're going to be doing. I have that. Now I'm not sure if I'm going to be using this. I have this Black & Decker RTX, which is pretty decent. It goes up to 30,000 RPMs. But one of the things I don't like is there is slack in this bearing in the very front. Even with it tightened all the way up, there's a bit of slack. Now one thing I like about this is the way it locks and unlocks. So you unlock it, it spins, you flip this up, and I'll take that back. There. You flip it all the way back, it locks, so you can easily remove your tool, which is okay. But you know, Dremels can be a pain in the butt, but I got a Dremel chuck, which, you know, on a Dremel you just press the button and you spin this out. And so I don't know, I'm going to try it both ways. Both of these mount very, you know, have the same similar type of mounts on them, although this one has a bit of a narrower, let's see if I can get it in the right here, the narrower part here, which, you know, you could put you know, make something to where it goes onto here, this goes into maybe 3D print something, fits into here, fits onto here, and I don't know. But basically the carrier for the 3D printer, where it had the extruder motors, that entire carrier still on this unit right here. All I need to do is adapt something to have the motor onto there, which I will be 3D printing something to go on there. Also, I have some bits, a high-speed cutter, and this little small, tiny little engraver. It's 1/8 of an inch. Well, not even 1/8. It's, they say this was. This was really, really small. Is it 1/8? Yeah, it's 1/8 inch. Okay. So it's a. No, it can't be, because it's an 1/8 inch shank, right? I forget now. Anyway, I don't care. I believe this is an 1/8 inch shank, but it did. Somewhere I was reading what this was. Anyway, it's a really, really small, fine little cutting bit. So I figure with those two and this, which I actually have a second one here. I think this first one they sent me had bad caps in it, which, you know, thanks to them. I mean, these guys that I ordered it from, they were real proactive. After I ordered it, they contacted me asking for me to look at the values on the capacitors on the board. And I did, and I let them know, yeah, it was the wrong value. These are supposed to be, see, this one is, let's see, 16 volt, 470 microfarads. The correct board they sent me, or I should say the second board they sent me, let's see, this guy has 50 volts. 50 volts, 100 microfarads. So it's not so much the capacity, it was the voltage. Apparently they just got the wrong voltage on here, which this 16 volts, yeah, if you're running a 24 volt system, which is what this is, then yeah, these would definitely burn up. So, which is not a real big deal. I mean, these guys were stinging awesome, if you think about it. They were proactive, and they went ahead and sent me another one for free and said, sorry, we screwed up. So this one, I probably will just put new caps in it, recap it just like the other one, and got another project that I will probably use this guy on. The other things that I'm going to be putting into this is going to be a camera, maybe 2 cameras, but probably just one, and I'm thinking about a vacuum system. The end goal of this, not only to create some small parts and different things and doing some engravings, but I'm also wanting to make my own circuit boards, in essence. So that's something I'm going to be doing. I'll get some FR4, try some single-sided cuts first, before graduating on to possibly some double-sided. I may end up making a different build plate. I can actually have, with the way this thing is set up, you can interchange out, say for example you have one that has clamps on it for doing, you know, small things like plastics and bits of wood or plywood or anything like that, and then you can have another one built for doing circuit boards, and you can have mounts for FR4 in your common sizes and have it where it basically clips in. You put your FR4 in and then you start cutting out your circuit board, and then you can swap out between the build plates here, which I think is going to be a really nice way of doing it. I haven't seen anything else like that, and I don't understand why. But in any case, this is going to be the first video of this, and the next video is going to be doing, well, it's basically going to be getting this guy wired up. And anyway, that's what I got going on. This is the beginning of this build, and hopefully you guys like it. Follow me, like this video, subscribe to my channel. You guys take care. See you next time.